This module is about the fundamental aspects of complexity in project management. In this module, we will see three things: characteristics of complex projects, dimensions of complexity, and the fourth is model. Start but by recognizing that there are many different types of complexity associated to complex projects. Thus, there is no one base model to manage complexity in projects. This is why in this course I present a range of conceptual tools. Some tools are more suitable for particular situations or type of projects. Other tools are more suitable for other type of situations or projects. A good example of project complexity is the Deepwater Horizon case. As you know, in 2010, Deepwater Horizon exploded, killing 11 persons. The cost of this failed project was close to $30 billion. This was the largest oil spill damage in nature. Of course, we know that offshore drilling is a technologically complex and expensive operation. In this specific situation, BP and Transocean, the owner of the platform, they were world leaders in offshore drilling technology. Transocean had experience in drilling in deep waters for many years ago. They do have 24/7 technical support. They did have all the equipment that they needed. They knew what tasks they need to perform. They knew how to do their tasks, and they had a lot of high-tech equipment, the best high-tech equipment for the offshore drilling industry. But it was the first time that BP and Transocean were drilling at such a deep. They have drilled before in the ocean, but not at this deep. And that was one of the key issues. But what were the main challenges in this specific case? First, there was what we call time uncertainty. So how long time the drilling task will take was mostly unknown. Why? Because it was the first time they were drilling at this deep. There was also task complexity because there were many parts, many mechanical moving parts and electronic moving parts, and they were using also new technologies, and those new technologies need to be combined with the mechanical parts. There was also context complexity in this case, and we can divide in two parts. First was the physical context because it was a very high pressure specific situation. You know that the deeper you are in the sea, the higher the pressure, and that changes everything in technical terms. What we do and you and how you do things. And second, there was an invisible contextual aspect that affected the Deepwater Horizon case, and this was the loose regulation in the oil in offshore industry in the U.S. by that time. Some years ago, before the accident, the Bush administration eliminated regulation in most of the oil and gas industry because they would say, now you will do self-regulation. And self-regulation, you know what it means. You know whatever you can, whatever you do, as far as there are no accidents and no issues. Another form of complexity that was associated to this case was organizational complexity. There was pressure on the people who work on the platform to drill faster. Why? Because Transocean was renting this platform to BP, and the cost was $1 million per day. So every additional day, it was significant loss for BP. So what we can observe in this case, that complexity is really a combination of different types of uncertainty regarding tasks, what to do and how to do, and context, physical terms, And in this case, it was in legal terms too. Then, what we can conclude from this example is that we cannot use conventional project management models to deal with complex projects. Conventional project management models do not account for uncertainty. Conventional project management models focus on planning and control because there is an assumption that you can predict and plan everything, you can control all activities, you know what to do, how to do, when to do, and you can control people. And of course, conventional project management models are suitable for this type of projects only, for projects in which you can mostly predict and plan almost everything. But they do not work, they are not useful in the case of complex projects. But not all projects have the same type of complexity. In this case, this is the water desalination plant that is located between Queensland and New South Wales. As you can see, there's no new technology here. There are many other desalination plants in other parts of the world that work very well. Now, when they were constructing this plant, they tried the technology in a small scale and worked very well. However, how it will work in a large scale when they really build the physical side, there was uncertainty. And the reason of this uncertainty is because the input, the seawater, is not exactly the same in physical and chemical terms than in other parts of the world. So the same technology may not work in the same way with inputs that are not exactly the same. In this case, this is an example of what we call technical complexity. Complexity can also be related to time uncertainty. That is, when something will happen or how long time do we have in order to perform a specific task. This is the case, of course, of the tsunami in Indonesia in the Boxing Day of 2005. There were, first, nobody knew when it will happen, of course. And second, after it happened, there was only a short window of time to rescue survivors. Also, there were very unclear priorities to the people who arrived there first after that tsunami. What were the priorities? Is water, medicines, roads, transport, food, telephone, water? Everything was needed, but we need some priorities. Next, also, it is difficult when something unexpected happens, it is difficult to measure the outcomes because, of course, the outcomes happening in a large geographical area, some areas were affected in a deeper way than other areas. Some areas needed some type of help and other areas needed another different type of help. So measuring outcomes is also difficult in this case of time uncertainty. And finally, there's also, because there are too many things that are needed and quickly, there's not a clear connection among the different tasks. That is, what is the relationship between roads, transport, water, and medicines, and food availability? Of course, there is a connection, but at the beginning, it is difficult to set what are the priorities. And this is a real example of time uncertainty. The discovery of a new drug or of a new vaccine, for example, is a combination, is a project in which there is a combination of technical complexity with task complexity. As we know, the development of a vaccine, for example, is a long-term project. There are many government regulations. It is knowledge intensive. It is necessary to have scientists from all over the world. with very, very specific and detailed knowledge. And there's also a stage of many clinical trials. But something that is important in the development of new projects or new drugs, such as in this case, or new vaccinations, is that there are many possible solutions. There are many ways of doing the same thing, right? Of course, some solutions will be more effective, more efficient than other solutions. But at the beginning, nobody knows what is the best solution. And there is no one best solution. Maybe there are a range of solutions. And the other point is that even after you have developed this vaccine or this new drug, the outcomes may be uncertain. That is, there will be many features of the product of the vaccination that are unknown, maybe collateral effects that may be unknown, for example. In this case of the vaccination for COVID, for example, yes, the market is very well known because the whole world basically needs uh, a vaccination, so there is a whole world market. But there is complexity related to technical aspects, right? Related to knowledge intensive solutions, and also task complexity, how to do all these tasks in a very organized and efficient way, right? And task complexity is also related to the issue that there are too many possible solutions. What is the best solution? At the beginning, you don't know. You need to do it and invest time and money in order to have an idea if this solution is feasible and going ahead, or if it is not feasible and not going ahead. The case of the COVID vaccination is a very good example. You can see that there are mostly three types of, there are many, more than three of course, but the three that we see in the newspapers are three vaccinations that use different fundamental scientific knowledge in order to arrive to the same outcome. If we think in the organization of Olympic Games, we will see that this project entails a very different form of complexity. As we know, organizing a Olympic Games project is a long-term project. There are many resources, regulations, and goods that are necessary for the development of this project. Now, because it's a long-term project, those resources and even regulations may change over time. Next, in this type of projects, there are multiple stakeholders, multiple organizations that can be public, private, national, international, and all them need to be connected, integrated in order to achieve the final goal. And also there is a time constraint that we need to mention. And the time constraint is because the opening day is a fixed day. If anything may happen, but the opening day needs to be in a predetermined date. All this means that organizing an Olympic Games involves multiple interdependent sub-projects. The key here is the integration of all those sub-projects. This means that coordination of all those different stakeholders who have different goals, views, resources, and priorities is crucial. In the case of the Beijing Olympic Games, for example, as you can see in this slide, there were too many organizations. Some organizations were government organizations, such as the Olympic Chinese Association and the Ministry of Sports, and other stakeholders were also national, but were related to the sports, such as the Chinese Swimming Olympic Association, Tennis Olympic Association. And on the top of that, we have the International Association of Swimming, Tennis, and all the other sports. Plus, we have the specific sub-projects that will develop or will be in charge of a specific infrastructure of the Olympic Games, such as telecommunications, roads and buildings, sport venues, health and safety committee, the opening ceremony sub-project. So the key point, as I mentioned here, is the integration of all those sub-projects which do have too many different stakeholders. Considering those examples, we can see that main characteristics of complex projects are first, time uncertainty that relates to how long time a specific task will take to be performed. Also, it can be related to when a specific event will happen. For example, in the case of the tsunami, nobody knew the exact date of the tsunami. In the case of task time uncertainty, we can think in, for example, one specific task in order to develop a COVID vaccine. There are parts that are need a lot of experience and work on laboratories and trials and errors, and nobody knows exactly how long time it will take. The next type of uncertainty that we have observed in this example is what we call market uncertainty. And the example here is that the company that developed drugs, do we have enough customers to have profit at the end of the process, at the end of the project? Nobody exactly will know. Because the success in drug companies is not immediately. And actually, in drug companies is very funny because they can develop a specific drug for something specific, let's say for coronavirus, and it fails. But it turns up that the same drug is not good for coronavirus, but it's very useful for another type of virus that is also important. So market, that is the type of uncertainty associated to markets, to who are our customers and the size of the customers. Another type of complexity associated to products is what we call technological uncertainty. That is basically how we do it. How do we do this project? How do we do this drug or this vaccine, right? Uh, Associated to this, it may be also the case that we know how to do it, but there are too many ways of doing this. And this is also another type of complexity that we call task complexity, because there are too many possible solutions and we do not know which is the best of these solutions because nobody knows, of course. And this is the case of the coronavirus vaccine. There were too many ways of doing the same thing, and which is the best in terms of cost, in terms of times, in terms of efficiency. Still, we don't know. The other form of complexity is product complexity. Product complexity, the example is the example of the Olympic Games, and I have already mentioned, is when we have a product that has too many stages and too many parts, and all they need to be integrated. So the integration becomes the key issue when we have product complexity. In product complexity also we have multiple stakeholders, and we know that multiple stakeholders may have different views and different resources and different priorities. And finally, we have environmental uncertainty. Environmental uncertainty is related to external factors to the project that may or that affect the project. Two examples, the tsunami case and second, the Deepwater Horizon case. There were environmental problems, external problems to the project that affected the project. In the case of the Deepwater Horizon case, for example, there were two things. First, the physical mechanism that was put deep in the water was not enough to cope with the high pressures on that deep. And second, the government regulations that didn't exist, that were very, very loose, that did not ask companies offshore companies to make some specific checks and balances. So there were two forms of environmental uncertainty that affected in this point the deep water case. While it is important to know about the features of complex projects, it is also very important to be aware of the main issues that are usually associated to complex projects. The first one is misaligned stakeholder view of success. And the point is that different stakeholders interpret success in different ways. Some stakeholders may see to the outcomes of the project in terms of costs. Others can be to the outcome of the projects in terms of time or schedule, for example. So it is necessary to consider that different stakeholders may have different definitions of view of what is a successful project. Next, we need to know or we need to be aware that the definition of project success cannot be disconnected from the product. In other terms, it may be a tension between product success and project success. Not always a project success means a product success and vice versa. And a typical example here is the construction of the Sydney Opera House. As you probably may know, it is considered, the Sydney Opera House is considered as a product, it's a total success. It brings millions of tourists and money and dollars to New South Wales, to Sydney. But as a project, the Sydney Opera House construction was a total failure because it cost 7 times more and it was delayed by 7 years. The next aspect is that we need to be aware are the political pressures against doing the right thing in projects. And I mean that sometimes in multi-million dollar projects, they are affected by political pressures. So it is important to understand the context, the political context of the project in terms of government regulations, how they change, or external events created by political pressures, will how they do affect the development of the project. Next, sometimes also another issue with project complexity is associated with a lack of understanding of non-technical issues in projects. Traditional project management focuses on the hard technical aspects of projects, resources and tasks and equipment and people. But in complex projects, the soft aspects are as important as the hard aspects, such as, for example, unexpected events, changing regulations, politics among stakeholders, and or simply people acting in an irrational way. We see this every day. So we need to consider the soft aspects of projects as much as the hard aspects of projects. Next, we need to be aware that sometimes competition is used as a weapon in project management. And we know that competition favors efficiency, but this only happens in open markets, that is, in markets in which there are a lot of competitors. But in semi-open markets, Competition is artificially recreated, and competition do not necessarily favors efficiency. And semi-open markets, for example, can be a private-public construction of a large infrastructure project. There's competition, but it's a semi-open market. It's not an open market. So the competition that is created is artificial. Then this means that it is necessary to be very careful when we are talking or we are dealing with this type of project, because do not necessarily will favor efficiency. Here in this slide we can see additional features of large complex projects. Large complex projects are highly customized combinations of products and services. That is, they have a lot of engineering and technology intensive services and or products. A very good example here is the construction of a large airport. They are high cost not only in the physical civil infrastructure, but also they have high cost because they have a lot of IT and mechanical equipment. For example, the baggage transport system. Also, these type of projects have high number of customized components. That is, components that are especially made, tailor-made for this specific project. So different components will need to be sourced from different suppliers, and this is an extra complication, let's say, to the development of the project. And finally, large complex projects also have a system nature of final products or services. So if we see an airport, if we think in an airport, it's not just one unit, it's really a system that is composed of different units. And in an airport, we can see that we have the air traffic control, that is, if we can consider just one system, but we have the baggage handling system that we can consider other system. We have all the operational mechanical maintenance activities of the aircraft that we can consider a different systems. And we have another system that is related to customs and police, that they need to be present to check who is in and who is out. So, and all these systems, subsystems, need to be integrated. That is why we say that complex projects have a system or network nature. Large complex projects, as I have already mentioned, do have usually multiple stakeholders that may have different goals and different understanding of success, and also different agendas. We can say that the main stakeholders we can categorize in primary and secondary actors. The primary actors in any project are, of course, the project integrators, prime contractors, main customers, the main end users, and the main suppliers. These are the key stakeholders that we are always seeing. However, there is another set of stakeholders that we call secondary actors, but they are not less important than the primary actors, just that we don't see much them because their work underlines the whole project, such as, for example, engineering scientists or research and development people who develop the technology in order to actually make the product. Or also insurers, regulators, and financiers. Without insurance, without regulations, without people who finance the project will not exist. There are also consultants to the project, and there are other interest groups that may not necessarily be related to the project at the beginning of the project, but at some stage it can be related to the project, such as, for example, we can think in a group that is interested in the environment, and this group may affect the development of the project. There are also external events that may affect your project. The first, of course, is changing market requirements. Nobody knows how the market will behave. A very good example, real example, is the case of the desalination plant that was built in the border between New South Wales and Queensland. This plant was built by the government because there was no rain for many years and the dams were at very low level, and they saw that it was a higher risk for the cities in southeast Queensland to not get enough water. So they decided to invest millions of dollars in this plant. After many years, when the plant was finished, when it was ready and started to work, there was a lot of rain, and that means that the dams were full for most of the years, and there was no need for this additional water. So the government had to shut down the plant. So the market requirements changed. Another external aspect that we need to consider are fundamental technology improvements. And the electric car is a very good case of fundamental technology improvements. You know that the conventional automobile have used petrol. There are hybrids too, but now there is Tesla that have a fully electric automobile. Now all the other automobile producers have got also electric automobiles. But this was caused by a fundamental new technology improvement that enable that we may have now fully electric cars. And this is related to the next external influence, that is no new sources of competition. Before the electric car, the big, large automobile companies in the world were GM, Ford, Volkswagen. Now, it is Tesla, GM, Ford, Volkswagen, and Toyota. Tesla is a totally new source of competition. They didn't knew that it will grow so as quick as Tesla has grown, and despite that their output is not large, is now more valuable than GM or Ford. The other aspect that is an external influence that is crucial in projects is regulation, because government regulations change. It doesn't change overnight, but it changes over the years and over the months. And because complex projects are long-term projects that may last 5 years, 7 years, or 10 years, in those 10 years, regulations may change, and that may be a key aspect that will influence on the success or failure of the project. And finally, I have written here human resources as an external force influence, in terms that our human resources that we do have in our company in order to develop the project, suddenly they can walk away overnight if competition offers them much more money that we are paying them in order to develop their project, and they just go away, and we are without a key human resource. So that is why I have considered as an external influence when we do not have, or when the people that skills that have competencies adequate for our project, they just simply disappear. In this slide, we have additional features of large complex projects. Please read in the following 3 slides a detailed explanation about these 4 aspects, and if you have any doubt about any concept that we have presented during this lecture, we can discuss in the collaboration session or in the face-to-face workshop.